Okay, let's write down everything that we learned so far and then add some more. Okay, so if you just integrate dx, this is another way of saying 1 times dx. So if you don't see anything, that really means 1 times dx. And what differentiates to 1? X. And then x to the n is the power rule for integrals. And then we also did integral of cosine of x dx equals to sine x. That's all we did so far. Let's now think about other things. So the next question is, what differentiates to sine? Does cosine differentiate to sine? No. Cosine differentiates to negative sine. So if you want to integrate sine of x, you should be getting negative cosine x. Always, when you are not sure, try differentiating. If you differentiate negative cosine x differentiates to negative sine, everyone knows that. And negative of negative is positive. So that's what we have. And then, what's the integral of e dx? That's probably the easiest. What's the integral of e dx? Yeah. Because e dx differentiates to e dx, it's the same thing. And to go one step more, what's the integral of a to dx? Well, if you differentiate a to dx, ln of a pops in front, right? So again, in this doctrine of preemptive strike, you want to put it there so that when it gets differentiated, the log of x, log of a that creates, will cancel this and give you this. So that's what it is. Now there are other things, but those are not very easy to do. Like for example, what's the integral of tangent of x? If you think about what differentiates the tangent of x, that's not an easy question. Okay? To do that, you will need. If you differentiate secant of x, you get secant x times tangent x, right? I mean, you can have statements like that. If you differentiate, since you differentiating secant of x gives you secant x tangent of x, that means that the integral of secant x tangent x dx is secant of x. Okay? Plus c. Keep yelling that. That way you're not going to forget it when you're taking the exams. Another thing is tangent of x differentiates to secant squared of x. So that means integration of secant squared of x dx is tangent of x. Yeah, but what's the integral of tangent of x? That's a completely different story. That requires something called u substitution, which we will not cover in this class. So there are several lists that are missing. We don't know what's the integral of tangent of x. Log of x, integrating log of x will require something called integration by parts, another new thing that you have to learn in Calc 2. So those are things that you won't get to see. Right? However, these are the lists that you have to be comfortable with for this class. Okay? All right. So using this, so these are the ones that you have to know. Using this, let's try to solve another initial value problem. Solve the initial value problem. So let's say you have a function whose derivative is given as 3 cosine t minus 2 sine t plus e to the t. And let's also say the initial value of the function is given as some number, let's just say 5. Let's try to solve this. And we can make use of these lists that we created. So first of all, f of x is the antiderivative of its derivative. If you take the derivative and you do the opposite thing, you're going to recover your f of x. All right, so we have to integrate 3 cosine t minus 2 sine t plus e to the t dt. I messed up. This should be all x's, right? Let's just change this as t. Right? Sorry about that. So if you differentiate and integrate, you come back to the function. You almost recover the function. Let's look at this list. What integrates to? What's the integral of cosine t? Sine t. So you have 3 sine t. What's the integral of sine t?
Cosine t.
Okay. And the integral of e to the t? E to the t. That's it?
Plus c.
Plus. So, because constants go away when you differentiate, when you integrate back again, you've lost this information. You forgot what that constant was. It's impossible to figure out what this constant was. And we have to figure that out by some extra information. And often that information is what was the value of the function in the beginning. If you have that, you can figure out the value of c. Okay? All right, so let's try this. What is f of 0 according to the formula that you created? Okay? 3 sine 0 minus, actually, negative is plus 2 cosine 0 e to 0 plus c. Now remember, the sine graph goes like this. That's the sine. And the cosine graph goes like this. Right? So sine of 0 is? 0. Cosine of 0 is? 1. Okay. So we know that this is a 0. 2 times 1. And then anything to 0th power is? 1. So you get 3 plus c as f of 0. On the other hand, what is f of 0 given as?
5.
Yeah, so you know that 5 should equal to 3 plus c, which tells you that c must be 2. Right? 2 plus 3 is 5. And then finally you put this back in there, and that's your answer. Okay, so your f of t is 3 sine t minus plus 2 cosine t plus e to the t plus 2. That's the final answer. I wanted to do this example not only just to show you how to use these formulas, but also in this case the initial value is not the same as c, right? So in constant acceleration motion, when you solve by integration, always the initial value is same as that extra c you created. But in general, that's not the case. In general, if you have like cosine, sine, stuff like this, then your c could be different from what's given. You have to actually do the computation. And if you look at the core idea of how this thing was solved, you first integrate and then you evaluate the function at 0 from what you're given, and then you compare it to the given value. Then you get an equation, you solve it. When you solve it, you get the final answer. Okay? A lot of times, people would stop right here. That makes me so sad when I grade. They're almost there at the finishing line, and then Like you solve something, the moment you solve an equation, you feel like, oh, I achieved something, and then that's where you stop. Always look at the question. You have to, when you're solving the initial value problem means, you have to figure out what that function was. So you have to say what function it was. So you have to take this value of c you got, put it back, and you have to plug it back into